Lesson 7.2 here. We're going to be graphing polynomial functions. And you're going to want to have your calculator handy, your graphing calculator, because we're going to use that. Again, those of you without a graphing calculator, you're going to have to plug in values by hand here, which will take a little longer. So it's obviously an advantage to have a graphing calculator with a table function on that. Okay, so here's what we're given. F of x is equal to negative x cubed minus 4x squared plus 5. And we're going to make a table of values. Now, before I get into actually doing the table, this is a cubic function. Okay, meaning its degree, and we just talked about that in the last section, degree is 3 because the biggest exponent on x is 3. Degree 3, the lead coefficient would be the coefficient on the x cubed term, which is -1. Okay, if you remember, if it's x cubed, okay, we're going to look at the end behavior. If it's odd, which it is, odd end behavior, your choices are it's either going to go like that, or it's going to start out and then it's going to be increasing from left to right. Remember, the lead coefficient being a negative, what it does is it's going to be down as you go to the right, which is going to be this one. So that lead coefficient of -1 says it's going to look something like that. Okay. At most, it will have 3 zeros, meaning at most it would cross the x-axis 3 times. Cannot be more than that. One other thing we'll write down, we can find the y-intercept. And remember, when you're given functions like this, the y-intercept is really the constant term. So the y-intercept is going to be 5. So we know that at 0, at x value of 0, y is going to be -5. Alright, so now let's make an xy table, or an x and an f of x table. And we're going to use our calculator, and we're going to plug this into y equals. So let's go ahead and do that. So into y equals here. So hit your y equals, and we're going to plug in our equation here, which is negative x, and I'm just going to hit my power key for x cubed. So negative x cubed minus 4x squared plus 5. I'll go ahead and hit enter. And let's change that so you can see that up there. Then let's go and to our table. So second and above the graph key. So here's our table. Now again, those of you without a graphing calculator, you're going to have to plug in some values here. As you can see, -7, we're at 152. I'm not going to put that in my table because we're not going to graph all the way up to 152 in the y direction. Even -6, 77, even -5, 30. But at negative, so we got to kind of look at what happens at these values. Okay, but at -4, we're at 5. So I'll actually, let's actually go back here and put that in. At -5, we were at 30. Now, we're not going to actually graph that, but we know the graph goes up really high as we get past -5. So at -4, we were at 5. At -3, we're at -4. At -2, we're at -3. At -1, we get up to a positive value of 2. And at 0, the y-intercept was 5. We already knew that. At 1, we're at 0. At 2, we're down at -19. And then as we get to 3, it's going to really go down fast. So if we graph this, now -530 I can't put on my grid, but -4, 5 is going to be right here. And we know it goes up really fast because at -5, it's going to have to be up at 30. So -4, we're at 5. At -3, we're down here at -4. So we're right here, which means it's coming down really steep. So somewhere there between -3 and -4, it crosses the x-axis. And notice where it changed from a positive to a negative. That kind of tells us one place it goes through the x-axis, or where the y value changed from a positive to negative. Then at -2, 2, we're at negative 3. So negative 2, we're at negative 3, which means now the graph starts to come back up. At negative 1, we're up at 2. So we're actually above the x-axis now, which means somewhere between negative 1 and negative 2, it crosses the x-axis. And again, if you look here, here's where it switches from a positive to a negative. So this is what we're going to be looking at zeros here in a second. At 0 and 5, or at 0 it's at 5. So we're up here, which means it comes up like this. And then at 1, we're at 0. So now it starts to come, it curves there. At 5, reaches kind of a highest point there. Now it comes back down. At 1, we're at 0. At 2, we're at negative 19. So it would shoot down really fast there. And if you go back to your table on your calculator, notice at, whoops, that's not what I wanted. At 2, so if we keep going here, notice at 2 we're at negative 19, 3 we're at negative 58, and then it really goes down awful fast there. So it doesn't curve back up anymore. Okay, now you can kind of see what the graph kind of looks like here, or if you hit the graph button, there's what it looks like. And that's kind of what we drew there. So let's go back here. And notice, and we'll get into this on the next problem, but notice this one actually has 3 zeros. This problem is just asking us to graph it, so we're basically done with the problem, but we will be finding zeros here in the next problem or two. And there are 3 zeros. So this is a cubic function. It does have 3 zeros, somewhere between, negative 3 and negative 4. Somewhere between negative 1 and negative 2, it crosses the x-axis, and also at 1. So no, we're not between integers on that one. All right, let's go to the next problem. Now we're going to actually locate the zeros. So we're going to graph it, and we're going to look at where it goes through the x-axis, because remember, the zeros are the x-intercepts. The zeros, or the roots of the function. So determine the consecutive values of x between which each real zero is located. It's kind of what I was doing on the last problem. If it goes somewhere between negative 3 and negative 4, you're going to state that. Okay, and here's our function. F of x equals x to the 4th minus x cubed minus 4x squared plus 1. Okay, now we know this is degree 4. The lead coefficient is 1, so it's positive. Remember, degree 4, even degree, tells us the end behavior is the same on both sides. Remember, odd goes in opposite directions, meaning up and down, okay, and then it depends on the lead coefficient, but the end behavior is the same. If the lead coefficient is positive, it tells us the end behavior for this one is going to be up. It's kind of like a positive x squared term. This isn't a quadratic function, but this is a quartic function, x to the 4th with degree 4. Okay, so this is going to be opens up because of the lead coefficient. I kind of said that over there. And at most it would have 4 zeros. Now it doesn't mean it does have 4 zeros, up to 4 zeros. Sometimes it will have less. So let's go ahead and plug this in and get our table. And again, if you don't have a graphing calculator, you're going to have to pick some values. I'd start at negative 4 or 5, plug them in, figure out your y values that go with them. But let's go to our graphing calculator. Let's go to y equals. Let's clear that one out. And let's put in x to the 4th. Oops. X power 4 minus x cubed minus 4x squared and plus 1. Alright, so I got that in y equals. I'm going to hit enter. Okay, now on my calculator you can kind of see what the graph looks like right now, but let's go to the table. And let's scroll up and look. So now, you see at -3 and -4, we're way up there at 73 and 257. So so at -3, we're at 73. I'll put that in here. We're not going to actually graph that, but at -2, we're at 9. At -1, we're at -1. At 0, we're at 1. Now notice the y-intercept. I didn't write it over here, but the y-intercept is the constant term. So the y-intercept, notice right here, that tells me the y-intercept is 1. So 0, 1. 1, we're at -3. 2, we're at -7. 3, we're at 19. And let's go back to the calculator and just see. I think it starts to shoot up awful fast once we get to 4. If we scroll down here. 3, we're at 19. Yeah, 4, we're at 129. So this is where it goes up real fast. Okay. So we're not even going to graph 319, but that's where it starts to go up. So let's look at plotting these points. Even -2,9 I can't plot because my grid doesn't go high enough. Okay. But we're going to keep in mind -2,9 would be somewhere, up here. So -1, -1 is here. So I know it's going up really fast because at -3 we got to be all the way up to 73. So it's going to come down like this. At -1 we're at -1. At 0 we're at 1. So here's what happens. It curves, comes back up. So at 0 we're at 1. At 1 we're back down to -3. So now it comes back down here. So that curves, comes back down. At 2 we're at -7. And my grid only goes to -6, but let's put it down there. At 2 we're at -7. So we'd be down there. Now at 3 we're all the way back up at 19. So what's going to happen is that's going to curve down there at -7 and it's going to shoot up really fast. And we'd have to be all the way up at 19 here. Now make sure when you draw this that you can't graph 319, but that we know, because we're looking for the zeros here, that has to be between 2 and 3. So I'm going to circle my zeros because they want us to locate. This would be the graph. Need arrows on the end. Okay. Notice the end behavior is up on both sides as we go to positive infinity and negative infinity in the x direction. The function is, the f of x is going up. Notice it does have 4 zeros, so we're going to state the zeros. Okay, let's go from left to right. So if I look at this one way on the left, notice that is, we're stating the x values are the consecutive integers which it's between. So we're going to say between -2 and -1. That would be this one. That would be this one right here. Then if I go to this one, that would be between 0. Well, let's go between -1 and 0. We're kind of working left to right, so somewhere in between. You don't have to estimate the decimal, you just need to state the integers they're between. And if I go to this one, it's between 0 and 1. And this last one over here, notice we were at 2, we were down at -7, but at 3 we're up at +19. So that kind of tells me it's between 2 and 3 here. So your last one is between 2 and 3. So when you're stating the zeros or the consecutive integers, that's how you need to do it. And if it actually crosses at an integer, you would just say 5 or 6 or whatever, depending on what the integer were across the x-axis. Alright, we're going to talk about relative max and relative min. Maximum min points, the graph at the right shows the shape of a general third-degree polynomial function. Notice its end behavior is opposite directions. Third degree. Point A on the graph, this point right here, if we look at point A, is called a relative maximum. Relative to the x values around it, it's the highest point. Now, it's not the highest point of the graph because this goes infinitely up, but relative to those x values that it's around, it's kind of a turning point. This one over here at point B, it's called a relative min because it's the minimum point in that area. It's not the minimum point on the graph because this goes infinitely down, but relative to that area. So we want to think of relative max and mins as kind of turning points where these functions turn and go the other way. Okay, so that's kind of definitions of relative max and min, which we're going to do here on this last problem. So, maximum min points. Graph f of x equals this. So here's the function they give us. Estimate the x-coordinate at which the relative max and min occur. And we're estimating the x-coordinates at which they occur. So this is degree 3, or a cubic function, which means the end behavior is opposite. Opposite directions is what I mean there. So I'm just writing down some things I know. So opposite directions. Lead coefficient in front of the x cubed is a positive 1. That means it's going to be going up as we go to the right. So opposite end behavior means it's going to be something like that. Okay, if the lead coefficient is negative, it's going down as you go to the right. So the end behavior on the left would be going up. Okay. At cubic, at most 3 zeros. So at most, it would cross through the x-axis 3 times. Let's go ahead and write down our y-intercept. We'll get the table of values here, but the y-intercept is 5. Remember, that's this value right here. Okay, so let's get the table function on our calculator, and let's plug that in. So y equals, let's clear that out. Let's put in x cubed minus 4x squared plus 5. And let's go ahead and hit second and table. Now you can kind of see, and let's go ahead and write down our table, but at negative 3 we're at negative 58, negative 2 we're at negative 19. So that's where it's going down really fast on the left. But let's go ahead and write some of these values down that are in our table. So x and, well, I guess it's f of x or y. At negative 2, we're at negative 19. At negative 1, we're at 0. At 0, we're at 5. That was our y-intercept. At 1, we're at 2. At 2, we're at negative 3. At 3, we're at negative 4. At 4, we go back up to positive 5. At 5, we're at 30. So if I plot these points, negative 2, negative 19 is going to be way down here somewhere. At negative 1, we're at 0. So I know the graph is really going down fast that way. Negative 1, we're at 0. At 0, we're at 5. So we come up here. At 1, we come back down to 2. So that's a turning point right there, and we'll talk about that in a second. At 2, we're at negative 3. So we come down to negative 3. At 3, we're at negative 4. So it comes and it actually goes like that. At 4, we come back up to 5. 1, 2, 3, 4, 5. So we're back up to 5. So that's going to turn right here and come back up and be at 5. At 5, we're at 30. If you scrolled out there, it'd start to go up really fast. Okay, remember opposite end behavior because it's a cubic function. All right. Now, if they said, what are the zeros of the function? The zeros of the function, now notice this one is at an integer, would be negative 1. We'd be between 1 and 2, between the integers 1 and 2, and between the integers 3 and 4. Now, they're not asking for that on the problem. They want the x values at which the relative max and min occur. And we're dealing with the x values for these. So, here's the relative. A relative max would be right here. So this is called a relative max. Now, the coordinate is 0, 5. Now, they want the x values, so the relative max occurs at x equals 0. The relative min, if we go over here, this would be a relative min right here, and we are actually at the coordinate 3, negative 4. But again, we want the x value that it occurs, so that would be at x equals 3. Okay. If they asked you what is the relative max, then that would be the y value. But they're asking what x coordinate does it occur at. Okay. The relative max is actually 5. Okay, if they said what value is the relative max and what value is the relative min, that would be -4. That would be the y values. They're not really asking for that here. They're just asking at what x values does it occur. So that's what you're stating, and that's what you'll be doing in your homework. And that's the lesson.